So 5.NBT.1. What this standard focuses on is recognizing that a digit in one place is 10 times as much as the value to its right. Now what that means, that's literally what it says in the standard. What that means is when you look at the difference between a digit, a place, and a value, a number like 325.12, those numbers, the 2 here and the 1 here, those are digits. That's the digit 2. That's the digit 1. That's not a big deal. It's just, that's what they are. Well, when you're referring to place, that same 2 is in the tens place. So that means something different. And when you look at value, that 2 in the tens place means that it's worth, the value is worth 20 because it's in the tens place. And the digit there, 2, when put in that place, the tens, has a value of 20. And you can do the same thing with the decimals. The digit 1 in the place, the tenths, has a value of 1/10. So that idea of place value is often the first thing that's addressed in a school year. And this place value chart, this is definitely an example of something you've students see since they enter kindergarten, starting with ones and tens. And by the time they're in 2nd and 3rd grade, they're working with ones, tens, and hundreds. And then 4th grade, they introduce tenths and thousands. And then, that should say 10,000s. By 5th grade, you're recognizing decimals all the way to the thousands and all the way up to the millions. Well, knowing that the decimal is always to the right of the ones place, that's something that a lot of students actually never really memorize. They just see it, they do it, but being able to describe the decimal as representing the ones, it's helpful because when you see a number like 25, lots of times students don't recognize that there's actually a decimal hiding to the right of the ones place. A lot of those little things, they come in handy later on, but for now, what I want to do is I want to look at two numbers like 250, where the 5 in the tens place has a value of 50. That's 5 tens. So when we consider what the standard is expecting, that a digit in one place, such as the tens place, is 10 times as much as the value to its right, that means that those 5 tens, that 50, is 10 times as much as the place to its right, as the value to its right, which in this case is the ones place. The 5 ones, when you compare it to the 5 tens, it's pretty easy to see that 5 tens is 10 times as much as 5 ones. Well, that idea, you have to get used to saying it in that way. It's really the words and being able to explain that becomes the challenge. So when you start looking at numbers like 250, 205, and 200.5, what happens is all of these numbers and all these language, all these words, they start to, I don't know, they get confusing sometimes. So when you break it down and you start really looking at it, the 5 in the tens place and the number 250, that 50, that 5 in the tens place, well, that's 10 times more than this 5 in the ones place. So 50 is 10 times more than 5. Well, the same rule can be applied when you look at the ones place, and the value to its, the place to its right would be the tenths place. So this 5 tenths, when you compare that to 5 ones, 5 ones is 10 times more than 5 tenths. It's the same rule. And what really gets me, and when I'm working with students, is trying to explain in this way how 5/10, if you were to have 100 of those, it would be equal to 5/10. Just the language of recognizing tenths times 100 equals tens, that's really tricky. So working with these types of numbers and these types of place values, they don't really serve a purpose beyond understanding how numbers are the way they are, why we write them the way we do. So you're not going to go to the grocery store and really have any fun explaining place value to anybody. You're not going to use it in any practical way, but it's going to be the basis for all of the explanations of numbers moving forward. So now when you look at a number like 735 and 573, if you underline the ones place in this 735, those 5 ones, well, that 5 is less than this other 5 in the hundreds place, because the value of this 5 is 500. So saying this 5 is less than this 5, when you're looking at it, you might say, okay, yeah, I get that. But then you have to consider that this 5 is how much less? It's 100 times less. And that brings us to part 2, which I'm going to talk about, because the other part of this standard is not just recognizing that this 500, is 100 times more than this 5, but that equally we have to be able to explain that this 5 is 100 times less than this 5. So we're going to stop here, and part 2 is going to pick up where this leaves off.